So today we will first start with the topic black body radiation, or what is a black body. So if you take an example such as iron, and if you heat that iron, first of all you know it will convert itself into light pinkish red, right? After that what will happen, if you heat it more, it will turn more red in color, and at a time you will obtain white. If you heat it more, you will obtain white color, and ultimately you will get blue in color. So you have started heating, you will obtain the light red in color, and then ultimately you will get blue color. So what is the observation? The observation is the color change, and every color has certain frequency. When you observe a color in a particular substance which you have heated, it means it is in different frequencies. Now you see, the frequency of the emitted radiation goes from a lower frequency to a higher frequency. So from higher to lower it changes. So when we have heated the iron rod or the iron substance, we have observed the red color first. So red color will lie in the lower frequency region, and the blue color, which is the ultimate color, that will be obtained in the higher frequency. So now the question comes, what is a black body and what is black body radiation? So there can be a substance, an ideal body, which can emit and which can absorb radiations of all frequencies. It means, in simple terms, if you heat a substance, you will observe all colors, from the light colors to the darker shades. So you can see that there are some substances such as such as a black body, which will emit and which can absorb radiations of all frequencies, and the radiation emitted by such a body, so you see it is a radiation emitted. So here you cannot use the term absorption, you have to use the word emitted. So a black body can emit and absorb radiations of all frequencies, but when we talk about the black body radiation, we have to see the radiation emitted by such a body or emitted by a black body is called a black body radiation. So this thing you have to keep in mind. And one more thing, why do we observe certain colors? When we talk about plants, why do we say that it is green in color? Okay, biologically it is the chlorophyll, but how we can see that it is green in color? It is because of reflection, right? So it means that the plant, or let us take the plant only. Suppose the plant is green in color, so why do we, okay, it is green in color, it exists, but how do we see? Okay, so that the question, the answer to this question is that the plant leaves absorb all the colors, but it will reflect, okay, it will emit only green color. It will absorb all color, but it will reflect, it will send back only green color, and that color we can see. Clear? The next question is, what is quantum? Quantum is the smallest quantity of energy that can be emitted or absorbed in the form of electromagnetic radiation. So it is the smallest quantity of energy that can be emitted or absorbed. Now, who named the term quantum? Who first explained it? It is Planck, okay, the scientist. Since we have talked about the energy here, the energy E of a quantum of radiation is proportional to its frequency V, and is expressed by the equation E equal to hV. So this is an important equation, and another important thing that you have to remember is the Planck's constant, whose value is 6.626 into 10 to the power minus 34 joule second. So this is a constant that you have to remember. It is the Planck's constant, and h is the Planck's constant here. Okay, here energy is directly proportional to value frequency, that is your V or mu, you can say. Okay, so E is equal to hV. So the proportionality sign is removed by using a constant, that is the Planck's constant, and its value is 6.626 into 10 to the power minus 34 joule second. Now we will talk about the photoelectric effect. So photo is related to light and electric is related to electrons. So both these will come together and form the photoelectric effect. Now let us see how the effect works. So first of all, in simple terms, you can say that light falls on a metal surface, and from that metal surface one electron gets separated from the metal. So this is the simple thing in photoelectric effect. This statement is say the phenomena of ejection of electrons from a metal surface when light of sufficient frequency or wavelength falls on it. It means that the light or the energy that is falling on the metal surface should be of sufficient frequency. The wavelength should be of sufficient unit so that electron is ejected or electron is removed from the metal surface. So let us study once more the phenomenon of ejection of electrons from a metal surface when light of sufficient frequency falls on it. So the energy or the light which is falling on the metal surface would be sufficient that it can eject an electrons, otherwise it will not able to eject the electrons. Now, when this happens, we can draw two conclusions. First of all, it is said that this energy is used for two purposes. Okay, we can draw like two conclusions. The first conclusion is that when electron is ejected, it means the bond is being broken. Okay, whatever bond with the electron, that electronic bond is broken. The next is that the electron was stable, but now it is removed. It means the electron is moving. It means the electron has gained some amount of kinetic energy. Clear? The electron is removed. It means the electron is moving out. The electron has gained motion, and we can say that it has some amount of kinetic energy. When we try to draw the conclusion in mathematical expression, then we can get the equation E equal to h mu naught plus kinetic energy. So E we already know it is equal to h nu. So h nu equal to h nu naught, that is we have written this h nu naught exactly as it is, and instead of kinetic energy we know it's half of mass into velocity square, half mv square. Now you already know what is h and what is nu. Then you already know what is h, but you don't know what is h nu nu naught. Now this nu naught is nothing but it is the minimum frequency that can be minimum frequency that required for the electron ejection. It is the threshold frequency. The minimum frequency is referred to as the threshold frequency. So it is the minimum frequency required to break the electronic bond.